Okay, problem number 3, we have a toy rocket moving vertically upward, passes a 2-meter high window, whose sill's 8 meters above the ground. The rocket takes 0.15 seconds to pass the window, and it's asking what the initial speed of the rocket was and how high it will go. And we're going to assume that this rocket exhausts all of its propellant in the very beginning there, so it's not going to be accelerating all the way up. It just accelerates that one spot. Okay, so let's see. Looking at just the window region here, I can say that my delta y would be equal to VIT plus 1/2 AT squared, where VI is going to be the velocity right when it passes the window here. And so this will be 2 meters equals VI times 0.15 seconds plus 1/2. The acceleration is negative 10 meters per second squared. Negative because downward, and the displacement's upward, positive. And then times 0.15 seconds. I have to square that. So I can now solve this for the initial velocity. 14 meters per second. So VI equals 14 meters per second. How about we do this? VF squared equals VI squared plus 2AD. That would work. Or delta y. So VF would be equal to the 14 meters per second. That's what we just found. VI is what we're trying to find, plus 2 times negative 10 meters per second squared times the 8 meters. So I get an initial velocity down here, or what I call VO, as being at the origin, 18.9, when I solve this equation, 18.9 meters per second, which is one of the questions. The other question is how high it goes. Well, now it's actually pretty easy because now I can just simply do kinematics on that to figure out that answer. And if I note the initial velocity here is 18.9, I know the final velocity at the top would be 0. I know the acceleration is negative 10. So I'm going to use that same equation again. VF squared equals VI squared plus 2AD. And the 0 squared equals 18.9 meters per second squared plus 2 times negative 10 meters per second squared times delta y. It's negative because if I'm saying that upward is positive, then the acceleration downward has to be negative. I get delta y to be equal to 17.9 meters for this one. And that's the height that it goes.